Hello and welcome to my final project presentation for course E63 Big Data Analytics. My topic was a big data case study in the Internet of Things. So let's jump right into it. Internet of Things is becoming like one of the biggest trends of our time, as well as like an increased focus on health. So I thought about a project that combines both, and what came out was the creation or the simulation of smartwatch users. So I created a producer which would produce data from multiple smartwatches from multiple users sending health data. And within my analysis, I focused on the use of the location attributes which are being sent, so your geolocation, as well as time series visualizations for several use cases. So starting off, we need to set up the environment. Those are the software packages and versions which I used. One note here, you can see that Elasticsearch and Kibana, I didn't use the most recent version, which would have been 6.00. That's because the Kafka Elasticsearch connector doesn't support, it needs multiple mapping, and that's not supported anymore in Elasticsearch 6.00. That's why I just used the earlier versions. But I'm waiting for an update of the Kafka ES connector so that we could update everything. But for now, we're just using the earlier versions. Getting started, I assume that all of you know how to install Java, Maven, Eclipse, and Kafka, because we worked with those, as well as Zookeeper. So I'm just focusing on Elasticsearch, Kibana, and the connector here. For Elasticsearch, pretty easy, straightforward. Just download the package, unzip it, and then cd into the directory where you unzipped it, and start off Elasticsearch by using the command /bin/Elasticsearch or / whatever it is in English. Kibana, same game again. Download the package, unzip it, and important, do that after you started Elasticsearch. cd into Kibana directory and then start it off with .bin/Kibana. To see that everything's working, go to localhost 56.5601. That's where Kibana is by default located, and you should see the working environment there. Next thing to do is go on the left side menu of Kibana here, and click on development tools, and then you would use a curl command using put smartwatches mappings, and then you would do the mapping for Elasticsearch. So what Elasticsearch needs for each index you create, because it's an index-based storage, you would just tell Elasticsearch what type of property you're inserting into it. It has an automatic mapping inserted, but there can be some issues with that, so it's better to just use a standardized mapping and put that in before. Using that command, you automatically create the index smartwatches as well. Here you can also see what kind of data I'm going to create with my smartwatches. So user ID, which uses using the smartwatch, a location, which will be longitude and latitude to locate the device, heart age, that's kind of like a combined score that would be calculated. It's just like how healthy is your heart, basically. Then a breathing index, again calculated, and it's calculated using your lung volume and stuff like that. Also gives an indication of how healthy you are. Then what kind of sports the user is currently doing. There's a selection of 5 types I have inserted into the simulator, which is hiking, running, swimming, skiing, cycling. The current heart rate, and a timestamp, so at what time the measurement occurred. So we're all set with Kibana and Elasticsearch. Now we're going to the Kafka Elasticsearch connector. That one is a bit more involved than the other two when it comes to installing, but it's manageable. So first you would use the git, like you would clone the most recent version from GitHub using the git command. Short note, I'm operating on Windows. I installed Cygwin, however you call it, to use Linux commands, but those are commands working on Windows. After cloning the package, the connector, you build the package, cd into the directory where you cloned it to, and then build a clean package. If that's succeeded, you should see basically this screen in your command prompt where it says build success. Afterwards, you have to go to the directory target Kafka Connect Elasticsearch blah blah blah, and then copy all the files in there, there are jar files in there, into the Kafka libs directory. Also in the Kafka Elasticsearch connector directory, configuration directory, you create an Elasticsearch -connect.properties file and insert the following content. So what you do here is you say which topic the connectors are connecting to in Kafka and to which index it should map it in Elasticsearch, and of course how it can connect to Elasticsearch, which runs by default on 9200. Then you go to the Kafka configuration directory, and there you'll find the file connect-standalone.properties. Again, just insert all that stuff here. It's basically saying that you're sending JSON files, where to connect to, and here we don't want we don't want Elasticsearch to infer a scheme, so we're setting this in false, and a couple of other things. And then finally we're ready to start our connector using this command. Again, just do that in command line. In that case, it's actually in Cygwin. This one here, however recognizes it, and then you should see this output. Also, you have to create, you have to start Kafka before you're starting the connector. I skipped those steps in the presentation now because we already did that in the class, so I assume that everyone can do that. Before you do that, also create a Kafka topic named smartwatches. And that's about it for the setup. We're all set, and then we can start the data simulation. I'll show you in a minute how that looks in real life. Let's check the time. Perfect. So what we're going to do is in Eclipse, I programmed the smartwatch simulator, and I'm going to execute it in Eclipse, but you could just execute the Java file, compile it, and then of course execute it from the command line. In the console, you see the data production. So after each message event it creates, it tells you what it just sent to what it just produced. So you can see the user ID, the breathing index, the heart age, sports, timestamp, and it goes a bit on further to the right. That is being directly sent to Elasticsearch. And now comes the exciting part. The use cases. What can you do with that? How can you use the IoT data to actually gain information? So use case A user heat map. So that's especially important for businesses, for example, want to know where their smartwatches are being used. For that, you just click in Kibana, left side menu, visualize, and then tile map. You would select smartwatch index, select count and location, and specify the heat map under options. I'll do that in a minute. Just quickly running through the other use cases. As I said, you can just the darker blue it is, the more people are using it there. So you can use that for advertising reasons, like do marketing in less in areas where your smartwatch is less used or something like this. Second use case, user within a range. So Kibana allows you to run a curl command on the data stored in Elasticsearch. And in our case, we're doing this to get users doing the same sports within like a certain range. So for example, everyone who's doing skiing in within a distance of 100 kilometers to the point X, that's arbitrarily chosen here, we would get a list of them. That looks like this. Here we get the list, who's doing that. Here you see the sports is skiing everywhere, and the user IDs are different. So you would just get different users from who are doing the same thing. That could be useful for users of smartwatches. So we would enable them to access this information so that it can group up with people doing the same sports nearby, because doing sports together is always more fun. Third use case, check the time again, perfect, okay. Third use case, average heart age. So as I said, heart age is generally considered as an indicator for how healthy you are. Again, we're making a tile map in Kibana, selecting the smartwatch index, specify the average, and heart age as variables, and then this is our output. The darker the dots are, the higher the heart age, the more unhealthy the people are in that area, according to the smartwatch data. And then governments could evaluate those health combustion points. We can also do an average heart rate over time, across all users or certain user groups. We just do that by, instead of taking tile map, we're visualizing a line chart, specifying the index, which is smartwatches, and average heart rate and date histogram as variables, and then just select the time range. That could, for example, be used to evaluate whether a health policy has an impact or not. So assuming that the higher the heart rate is, the more stressed people are. Maybe they are more sporty, but you could just see how this could vary. We could introduce a stress level as a data point from our smartwatches and infer policy implications from that. Use case E, popular running times. So if you go on the left side in Kibana, you click on Discover, then you select the property you want to filter by and select the time range in the upper right corner. You can get, you can see when people, here, let's just try this, I selected running, when the most people are running over the course of the day. You could maybe adjust advertising campaigns to that. Pros and cons. Pros, I forgot that file, sorry, that slide. Generally, pros, it's very, once it's set up, Kibana and Elasticsearch are a very powerful tool together, because it's very intuitive, and you can create a lot of visualizations and analyze your data visually and kind of see what's going on very easily. Cons, kind of hard to set up, especially getting the mapping right, setting up the connector, and connecting that to Java takes some time. But generally a very helpful tool, very easy to connect to other services as well. Con as well is that it only stores raw data basically, so you cannot manipulate your data within Elasticsearch. You have to do that in a third-party program. Okay, now quickly running a demonstration. So this is my class here. I'm just running this now. So starting, it also opens up a window where you could see the splits of the data being created. So the events, number of events split by the sports. The events which are being created you can see here. And let's check Kibana. So just if you click on Discover, you just get, I'm still on my running filter here. You can see all your data which is being inserted in Elasticsearch. To visualize that, you can just click on Visualize here and just go New. For example, we're creating a heat map. Clicking on selecting the index. Count is perfect. Geo coordinates. It automatically sees that our location field is a location, and then we just map it. I limited the range of locations to close to cities close by to Frankfurt. So that's why we're only having some dots here. So we have to zoom into this. And now you can see where our smartwatch is being used. The dark red dots are being, the more red the points are, the more our smartwatches are being used. Another thing we can do is a line chart. Again, select the index. Select, for example, the average of the heart age. On the x-axis, we're doing a date histogram, so just see it over time. And then interval, let's do auto. And we see this wonderful graph here. It looks very messy because my data is generated at random, but you could infer trends from here. For example, queuing our data index, what I showed you earlier. Let's select sports running. Who else is running within a radius of 150 kilometers? And there are a total of 2,721 people running at the moment within 150 kilometers, which is a lot. And you could get their locations here. Then the user IDs and so on. So you could send that data on to your consumers and help them to find other people and group up with them. We're still generating events until I stop it. That's about it for my presentation. If you have any more questions, hit me up, and